Hello everyone. Um, let's hope this new little toy I have helps you out with this particular section. So what we're going to look at is the section on volume. So if we're looking at volume, okay, volume of prisms and prisms and cylinders. Prisms and cylinders. Okay. Now, if you'll notice in your book, the area formula for a right prism or right cylinder is the same thing for an area formula for a general prism or general cylinder. Just because of the way the shapes of the figures are designed, they're basically starting with a base on the bottom and just going up in height. So the volume formula ends up being the same no matter what kind of prism or cylinder it is. So we say that volume is V equals B times H. Now B in this case is the area of the base. The area of the base. So let's look at an example of this. Let's look at a rectangular prism. So we have a rectangle here and a rectangular prism that looks like this. Excuse the drawing. Okay, so we have a rectangular prism that is 7 centimeters by 4 centimeters, and with that particular prism, it has a height of 3 centimeters. Okay, so when we're looking at the area of the base, we're going to try to find our B first. B is the area of the base. Now think of what the base is. The base for this particular problem is a 7 by 4 rectangle. So the area of that rectangle is going to be 4 times 7, since area happens to be length times width. So 4 times 7, which is 28. Now this is going to be centimeters squared because this is 7 centimeters times 4 centimeters. So that's square centimeters. Area is always in square centimeters. So we have V equals 28. Now that was the base times the height. Now our height here we said was 3, if you notice. So our height is 3. So that gives us 84. Now 84 what? This gives us 84. This gives us 84 centimeters cubed, because this 28 is centimeters squared times 3 centimeters, which gives us centimeters cubed. Volume will always be in cubic units, whether it's centimeters, feet, whatever. Volume's in cubic units, just like area is in square units. Okay? Now, just to show you that it works the same for cylinders, let's look at a cylinder. And let's make it where it's not a right cylinder. Let's look at one that this is what we call an oblique cylinder. And the oblique cylinder has a height of 7 feet. The the diameter of that base is going to be 6 feet. So what is the volume? Well, again, volume is capital B times H, capital B being the area of the base. So the base is essentially a circle with a diameter of 6. A circle with a diameter of 6. So remember what the area of a circle is. That is pi r squared. Now, r squared, the radius is half the diameter. So since our diameter is 6, that means our radius is going to be 3. 3 squared, which is 9, which is 9 pi. Okay, 9 pi. So our base here is 9 pi. Now it's 9 pi what? This is 9 pi square feet. Okay, so this is square feet. So keep that in mind. Times the height, which is 7 feet. So our answer here is 63 pi cubic feet. Cubic feet. All right, so now sometimes they'll want you to put 3.14 in for pi. So 63 times 3.14 would give you around 198 cubic feet. So, you know, I'm fine on test with you leaving it in terms of pi, unless I just absolutely ask you to put 3.14 in. Feel free to leave it in terms of pi. So this would be the volume of a cylinder and the volume of a prism. Okay, same formula. Whether it's a right prism, a right cylinder, it doesn't matter. Oblique, because notice this is a right and this is an oblique. And this is oblique. So keep that in mind. It does not matter which one. So on to the next one. Let's look at, let's change up to green just to change the color of things. Let's look at the volume of a pyramid or cone. Now again, these have the same formulas for one another because of the same general tendencies. If you remember a pyramid and a cone, they both have a flat base that forms up to a point. Okay, so they have general tendencies that are the same. And what we say is this, and the proofs for all these are in your book if you want to see the proofs, but this is not a geometrical proof class, so we're just wanting you to be able to apply the formulas. It's the reason I'm not proving them to you, but, and I'm sure that just saddens you, but it's going to be enough for you to remember these. So remember, this is volume equals 1/3 capital B times H. Now, capital B, again, is the area of the base. Okay, that has not changed. So, let's look at a pyramid. We have a rectangular pyramid that is 12 feet by 8 feet. And so, here's our pyramid, poorly drawn by Mr. Francis. Okay, so here's our pyramid, and the pyramid has a height, and the height extends down from the vertex of the pyramid. That height is going to be 10 feet, so that distance is 10 feet, okay? So that tells us what our height is. So, again, we're looking for B. B is the area of the base. So the base is a rectangle, 12 by 8, so we know that our B here, that area is going to be 8 times 12, which is 96. Now it's 96 square feet, because it's 8 feet times 12 feet. So that's 1/3 times 96 times the height. And the height here happens to be 10. Okay? The height here happens to be 10. So 96 times 10 divided by 3 basically is what we're doing here. And so that should give you 320. Now that's 320 what? Cubic feet. Because remember, 96 is square feet, 10 is feet, so feet squared times feet is feet cubed. Okay, so that's where we're getting our cubic feet from. So this would be how we would do a general pyramid volume. Well, let's look at a cone because it uses the same formula. So we have a cone here, and let's pretend I drew that correctly. We have a cone here, and this is what we call a right circular cone. So the height here is 12 centimeters, and let's say our diameter of our circle here at the base of the cone, let's say that's 10 centimeters. Alright, so it's volume equals 1/3 base times height. 1/3 base times height. So we need to find the area of the base. Now the area of the base here, this base is a circle, so that's pi r squared would be the area of a circle. So again, we were given the diameter is 10, so the radius here would be 5. So 5 squared would be 25, so that's 25 pi. Now, that's going to be what? Square centimeters. Square centimeters. So, you could put 3.14 in there and get me a number answer if you want to. Again, I'm fine with you leaving that as pi. Now, be aware, though, that my math lab will a lot of times make you put 3.14 in there, and they will actually tell you in the problem when they want that. So go ahead and take your height, which is 12, plug that in, and multiply it all out. And let's go ahead and put the pi in our answer. So this is going to be 100. Excuse my writing with this new pen. I'm still getting used to it. This is 100 what? Since it's volume, it's going to be cubic centimeters. 100 pi. Excuse me. There should be a pi in there. 100 pi. Okay? Now, let me rewrite that. That bugs me. 100 pi. Now, like I said, you could put 3.14 in there, and you would get 314 cubic centimeters if you put 3.14 in for pi. And like I said, sometimes my math lab will ask you to do that. So, here's a couple of general problems for the volume of a pyramid or a cone. Now, last but not least on the volume is the volume of a sphere. So let's go to the next slide. Let's change up our color. Let's go blue. I'm in a blue kind of mood right now. Alright, so this would be the volume of a sphere. And the volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. So if we have some sphere, which would be very easy for us to draw. Let's see, we have a sphere. Okay, here we have a sphere, and let's say the diameter of that sphere is 10 centimeters, okay? And we want to know the volume. Now this one should be fairly straightforward. We're not having to find the area of the base or anything like that. We were given the diameter is 10, so that means the radius would be 5. Radius is half the diameter, remember. So this is going to be 5 cubed. Now it's 5 centimeters, so that means our answer here is going to have cubic centimeters in it since it's 5 centimeters, since that 5's being cubed, okay? So 4/3 times pi times 5 cubed. Now 5 cubed is 125. So 125 divided by 125 divided by excuse me, 125 divided by 3 is going to give us a decimal. So we can just leave it, multiply this out, and we'll get 4/3 times 125 times pi. Now, for this particular problem, what we have is, excuse me just a second.